Hi, math lovers. Today we're going to go through some vocabulary review of addition and subtraction of polynomials. So here I have some vocabulary for you, some things that I know you're already really familiar with. We talk about a term. We have terms of numbers that we're going to go ahead and add and subtract together. The numbers in front of them are called the coefficients. Our coefficients is the constant in front of the term. All right, we want to make sure before we add and subtract, we're always going to have a like terms. That's really important. You're comfortable with monomial, binomial, trinomial, so forth. Let's scroll down here to our degrees. All right, let's think about the degrees of the polynomial. So if I have a monomial, just one term, and I have a couple examples here for you. If I just have let's start this one, 5x to the third, y to the seventh. Look at those exponents, add them together, 3 plus 7, that gives you 10. Your degree here is 10. Same with the binomial. If I have a binomial, 6 plus 2x to the third, the highest exponent there, power, is 3. Degree on this monomial that we started with, that was 0. Degree on this term is 3. Which is higher, 3 or 0? 3, right? Good. Okay. So I have some examples here. You can see that the first A, this is a trinomial. I have 1, 2, 3 terms, and the degree is 7 because 7 is the highest exponent power on the term. B is not a polynomial. Notice that we've got a variable in the denominator there. And this steps, letter C, this is a monomial, one term, and the degree here is 5 because our exponents 3 and 2 add together to give me 5. Okay. You're really familiar with adding and subtracting. I'm not going to go through this with you because I know you've mastered this before, but I want you to pay special attention to the fact that they're going to kick it up a notch. They're going to throw different variables at you. You've got to be aware here. This first one's pretty easy because we've got the y to the fourth. So we add the exponents. In the second problem, please be careful with the minus sign in between. I would always go through and distribute that minus sign first. That's an area that I have trouble with. I don't want to lose my negative signs. So right away, I go through and I change this minus m to the third to negative m to the third. And then a negative times a positive gives me a negative here, and a negative times a negative gives me that positive right there at the end. Be careful as you add. Make sure you have like terms. Okay, this was what I was talking about in letter C. Notice that they've added 2 variables here. All right, so just be careful that you line them up correctly. This problem is great. It's combining multiplication and it's combining subtractions. So again, first you're going to distribute your 4 to all your terms. That's what I have here in the beginning, this first term, this first polynomial. And then I'm going to distribute the negative 5. So be very careful with that. That's my second polynomial. Then I'm ready to go through and add my like terms. Multiplication, I know you've seen me use the Punnett square before. Punnett square keeps me nice and organized. Notice my first term has 3 terms. My second polynomial has 3 terms. So I'm going to draw a box that's 3 by 3. I go through and I do my multiplication. You can see here how I've circled my like terms together. And I'm going to go ahead and expand it, add it up. Beautiful problem. Takes a little bit of time. Do not try to do this one in your head. We've spent a lot of time foiling before. Again, if you want to use my Punnett square, use the Punnett square. Remember, foiling is your first, your outside, your inside, and your last. You're going to multiply those terms together. So again, be very careful with that. Make sure you're adding your like terms. Notice in this second problem, we have the difference of 2 squared. So it's 2x and 2x, 7 and 7. And the thing that's different is the minus sign in between. When I go ahead and I add those together, the middle terms will fall out. So I'm left with the difference of 2 squares, which is just absolutely beautiful. And you know that as this rule right there. Okay, so use that to your advantage. In this problem, I like this one because first they're going to go ahead and you're going to see difference of 2 squares super quick. And then you distribute your exponent to it. Okay. Some other special products are where you have a square of a binomial. You know, if you don't notice this right away, you can always write it out. Like this first, let me show you, like this one, letter D. You know what? I didn't feel like in letter D, I didn't feel like just going back to the rule. So I wrote it as two polynomials times each other. And I went ahead and I FOILed. So I added that middle term together. It's just beautiful. And same thing with letter E, which is much more exciting. Notice we've got a y to the fourth in there. Ooh, y to the fourth. So you're straight up writing two sets of parentheses. Now, if you wanted to do the Punnett square method, you totally could do it that way, where you'd have 3x and minus 7 y to the fourth, and 3x and 7 minus 7 y to the fourth. Okay, you could go through and you could multiply that together. And notice how nice and neat these terms would stay, okay, as you went through. Have fun with your problem set.